So bronze is alloy of copper and any other element than zinc. So here some of the pictures are reflecting the applications: copper tin, copper beryllium, copper nickel, and copper aluminum. So out of these four, one by one explanation we have studied in the last class: copper tin, copper whatever we nickel, copper beryllium, and as per their application, see, I have shown the pictures. Bell metal, short note may be asked, it is copper tin alloy. The statues are made up of copper tin. Imitation jewelry are made up of copper aluminum. Then these registers are made up of copper nickel, and these springs are made up of copper beryllium. Copper beryllium question may be asked in the examination. Explain copper beryllium alloy is used in coal mines. Okay, so I have explained you how it performs the properties of tools, because it is having good strength, hardness, good resilience. These all are properties of tools. So it performs the properties of tools. But property it is having, that extra property is non-sparking in nature, which still, so the tool which is made up of steel, so it is sparking in nature, and there may be cause of explosion in the coal mines. Here, if we use this copper beryllium, then there is no such danger, and it fulfills the work of doing cutting operations. That's why copper beryllium is used in coal mines. So this part I have explained you. Copper nickel and German silver. What is the specialty of when zinc is added? So it gives good resistance to action of food chemicals and water. Okay. This copper aluminum is the finest color in all the copper alloys, lustrous appearance. That's why it is used for making the imitation jewelry. So this part we have studied in last class. Today we are going to study aluminum alloys. Write down in notebook. I hope now I have to keep faith on you. You are writing. In classroom, what happened? Teacher can check whether you are writing in reality. Here, faith is only required. Yeah, I am telling to write, and whether you are writing or not. So if you are not writing, means you are cheating yourself. Aluminum is one of the important non-ferrous alloy along with copper. So in day-to-day life, we are observing two non-ferrous alloys. First is copper alloy, second is aluminum alloy. If you see anywhere other than steel and cast iron, you can see aluminum and copper alloys. So which are these areas? So you can easily see the MBCB lines, high tension lines of electricity are made up of aluminum alloys. Your aeroplane, almost more than are made up of aluminum alloys. You take any automobile sector, any parts of the automobile nowadays, maybe manifold, casing, input line, then any parts of the body, then your foxes are replaced by the aluminum rims. I have not seen aluminum rims of the two-wheeler, four-wheeler. All these parts are made up of aluminum alloys. So this picture again shows this piston. See my cursor. This is a piston. These are piston rings, and this is a rod. This is the best example of aluminum alloys. Okay, cylinder head, pistons, all are made up of aluminum alloys. So now what is written in the slide? Check. It is having good thermal conductivity, good ductility, and excellent corrosion and oxidation resistance. Aluminum, so you can write down somewhere and make star. When I am telling important thing, you have to write at the upper side. Now turn the pages back and effect of alloying elements on steel. Have you written killed steel? Whether I have explained you killed steel, any student who's always writing sincerely in the notebook, please reflect at that time when I was teaching steel, whether I have explained you killed steel. I think I have explained. Samruddhi. Samruddhi. Roll number 1. Yes. Okay, she's saying yes. Any other student? Dhanashree Sonone. Whether you are knowing anything about killed steel. Dhanashree Sonone. Roll number 6. Yes. So for others information, those who are not knowing, I will explain. Aluminum is strong deoxidizer. Now here we are studying aluminum alloys means aluminum is base. But in the steel, aluminum was used as an alloying element. So when aluminum is added in the steel, it kills the oxide. Killing means not actual beating. It means it deoxidizes the oxides. So it kills the oxides. That's why the steel which uses aluminum as an alloying element is called as killed steel. KILLED. Turn the pages back of notebook and check whether you have written. If it is not written, then in the upper side where the effect of alloying elements I have explained, there you write killed steel dash. Aluminum is added in the steel for deoxidization. It kills the oxides in bracket. It deoxidizes the oxides. Hence, the steel is called as killed steel. This is the interview question as well as oral question. Whenever I say the interview question or oral question, you have to please note it down on the side of your notebook. Wherever you are writing, in upper row, where you are writing the titles. Now, let us see the aluminum alloys. So I have taken reference in the steel, and that's why we have gone back to that side. There are two types of aluminum alloys. One is cast aluminum alloy, another is wrought aluminum alloy. Remember these two important words. Wrought, WROUGHT, means alloy which is suitable for cold working deformation. I repeat, wrought, meaning of the word wrought is that is suitable for deformation. You can shape by deformation, forming process. Basically, in manufacturing process subject, we have studied two sections. Section 1 was casting completely and another was forming. So wrought iron and cast iron. I repeat once again, if you Google, you will read cast iron, which can be casted, wrought iron, which you can produce by or give the shape by deformation. Actually, from the uh, uh, furnace cupola, when you are going to separate or if you pour, you will get the raw material. Okay, that is cast iron. And from the blast furnace itself, if you want to produce the steel, you know that the percentage of carbon is less than 2. So accordingly, it is separated in the blast furnace itself. Means decarburization takes place. That's why wrought iron and steel are from the same category and cast iron is from different category. Wrought iron have less than 2% carbon. Now, this wrought aluminum alloy is soft, it can be deformable. Cast aluminum alloy, you can fluidity. That's why you can shape the parts by melting and pouring. Let us go to next slide. Reading one important statement here: silicon, copper, magnesium, nickel, etc. are the important alloying elements of aluminum. So in this chapter, in this bit, we are going to cover two important alloys of aluminum. One is aluminum silicon and another is aluminum and copper. Okay. So only one slide I have finished by the time. Second, you have to draw this diagram now. Aluminum silicon system. Definitely, if you check any previous question paper, you find the question on this for 4 or 5 marks. Explain aluminum silicon system. Or second, explain modification treatment given to aluminum silicon. Justify modification treatment is given to aluminum silicon system. So how to explain that I will put in front of you in the next slide. Before that, you write ALSI system and start drawing. So I will explain how to draw. Just draw x-axis, y-axis. Here the dotted lines you are observing. So you take tick is shifted to right, and this dotted is modified diagram, and without dotted is original diagram. You have to draw both diagrams the way in which I have drawn here. And this is only part diagram. That's only up to 16% I have shown. Up to 100% it is of no use. Only up to required level I have shown the diagram. Somebody reflect, the diagram is over. Snehal Mane. Snehal Mane, roll number 4. Whether diagram is over? Hello? Am I audible?
Huh?
Audible.
Sir, voice is
Okay.
breaking.
Actually, few students may suffer in this listening because of maybe internet problem. From my side, there is no problem because other students are able to listen. So I received that diagram is over from 1 or 2 students. Okay. Now look at the diagram. You look at on mobile or in your notebook. Okay. So this 11.7. Before that, I explained maximum solubility of silicon in the aluminum is only 1.65%, and it is almost less than 1% at room temperature. Only 1.65%, and it is at higher temperature, around 550 degrees Celsius. Now, what is the specialty of this diagram? As silicon increases, properties increases. Now I am going to next slide, but you keep the diagram in front of you from your notebook. Okay. Many times what happens, if you not draw diagram in the notebook, and if I will explain here, you may not understand because diagram is not in front of you. Now diagram from your notebook is in front of you, and now I am explaining this. So I explained already the percentage of silicon at 577 degrees Celsius is 1.65. And if you read the diagram, you will see eutectic is available at 11.7%. Eutectic means what? The composition at which it shows lowest melting point. So 11.7% silicon and balance aluminum shows eutectic. Now, what is the concept of modification treatment? The slides are in front of you. Just I will explain you. Whether if you want to see the slide and figure, both simultaneously observe. What happens if silicon percentage increases, properties increases. If you go on adding the silicon, mechanical properties go on increasing, fluidity properties go on increasing, corrosion resistance go on increasing. Okay, but unfortunately, the properties of eutectic are not good. Means if you go more than 10%, you are reaching towards eutectic point. Means I can explain aluminum 5% silicon have better properties, aluminum 8% silicon have little less properties. Why? Because I'll go back to diagram. See, at 11.7%, eutectic is, what is percentage of eutectic at 11.7? Eutectic alloy, 100%. So if you move from left to right, this phase is alpha. Okay. So this alpha plus eutectic, and if you move from left to right, amount of eutectic go on increasing at 11.7%, eutectic is 100% and alpha is 0 in this way. Now, as silicon increases, properties increases. This is one statement. Second statement, as amount of eutectic increases, properties decreases. Both statements are contradictory. So what is your limitation? What is our limitation? We want more silicon, but limitation is 11.7%. Up to that, if you go, you have to unknowingly, म्हणजे आपल्याला गरज नसताना युटेक्टिकच्या प्रॉपर्टी पण येतात त्याच्यामध्ये, ज्या थोड्या ब्रिटल आहेत. Then what is solution? Solution is modification treatment. What is modification treatment? If you add small amount of sodium, written here, 0.005 to 0.015. If you add this small quantity of modifying agent, your cooling behavior changes. So earlier, at 11.7%, it was showing eutectic reaction. Now I will take 11.7% of silicon and I will take balance aluminum and I will add this sodium and I will melt it and I will pour. So with addition of sodium, if I pour, it will solidify as a hypoeutectic alloy. It will not show eutectic 100% eutectic reaction. Why? Because of addition of this sodium. It shifts the eutectic to right and lowers the eutectic temperature. Same thing is shown here with dotted line. Okay, this cursor I am taking towards the diagram. Now friends, earlier the alloy was eutectic and it becomes now hypoeutectic. So hypoeutectic alloy have better properties. Means earlier my limitation was I can't use 11.7% or 12% silicon. If I use 12% silicon, my eutectic phase is more and it deteriorates the properties. मग आता मी काय केलं, सोडियम त्याच्यामध्ये ऍड केल्यामुळे तो जो युटेक्टिक ट्रान्सफॉर्मेशन व्हायचं मीन्स L that gives S1 plus S2 only 100% mixture. There is no pure S1 or there is no pure S2. Instead of that, my microstructure will be S1 plus S1 plus S2. म्हणजे S1 सेपरेट आहे आणि मग S1 plus S2 चं मिक्सचर आहे. S1 separate is rich in silicon and as silicon percent is more, there are good properties. So I can take benefit of more silicon. म्हणजे मी जास्त सिलिकॉनचा वापर करून घेऊ शकतो. जास्त सिलिकॉनचा वापर करून घेण्यासाठी ही युटेक्टिक रिएक्शन तिकडे शिफ्ट करावं लागते, सोडियम ऍड केल्यावर तसं होतं. विदाउट विच युअर अर्लियर alloy will solidify as a hyper eutectic which is having poor properties, and hence to take advantage of more silicon, modification treatment is given to ALSI system. Last sentence you read. Thus we can take benefit of more amount of silicon in a hypoeutectic alloy because this refinement takes place and improves the mechanical properties. Means if eutectic temperature refinement takes place, see the eutectic temperature. Earlier dark line it is at 577. Now this dotted line is almost T or 540. So eutectic temperature decreases means properties improve. Okay, so this is called as modification treatment given to ALSI system. It is asked for 4 marks. Can write it important points. I am keeping the slide in front of you. So very basic thing, hypoeutectic alloy is having better properties. Hypereutectic and eutectic alloys are having poor properties in case of aluminum silicon. If you take 12% of silicon, it is hypereutectic alloy. I repeat, if you take 12% of silicon, it is hypereutectic alloy because eutectic is at 11.7. And if you melt and pour, it will give hypereutectic composition which is having poor properties. Now what I am doing, I will take same alloy, I will melt and I will add some sodium into it. When I will add sodium into it, the alloy which was separating as a hypereutectic, it will separate as a hypoeutectic because of shifting of eutectic temperature. That is the effect of the sodium. So earlier your same alloy was hypereutectic and now because of addition of sodium it becomes hypoeutectic. And if you check the properties of case 1 and case 2, we will find that case 2 after modification gives better properties and hence modification treatment is given to ALSI system. Whether you understood?
Yes, sir. Yes, I understood.
Shall I go to next slide?
Yes, sir.
And if even writing speed is little less, there is a scope for taking screenshot. Later on, you can write it down in the notes. Okay. Next alloy is aluminum copper alloy. This is very important alloy. Here I am going to explain you precipitation hardening. So today only this will not be over because I have to explain precipitation hardening to you, and remaining part only 10 minutes are remaining. Let us see how can we cover. Maximum solubility of copper in aluminum is 5.65% at 548 degrees Celsius. Solubility go on decreasing with decreasing temperature. Now, what is the specialty of this alloy? The specialty of this alloy is this alloy exhibits precipitation hardening. Exhibits means ह्या alloy मध्ये precipitation hardening ही property आहे. Precipitation hardening means what? If you heat, soak and cool, and if you keep in atmosphere, म्हणजे पार्ट हीट केला, सोक केला आणि कूल केला आणि असंच टेबलवर ठेवून टाकला. आता टेबलवर ठेवल्या त्याची हार्डनेस मोजली, समजा ती आली 10 RC, रॉकवेल हार्डनेस 6 स्केल. यू गेट दिस इन्फॉर्मेशन इन टेस्टिंग चॅप्टर. RC ही युनिट आहे. सो 10 RC हार्डनेस आली. आता आज दिवसभर गेला, उद्या मी परत आलो आणि त्या कंपोनंटला परत एकदा घेतलं आणि परत हार्डनेस चेक केली, तर उद्या 12 RC येते. सोमवारी 10, मंगळवारी 12 RC. परत बुधवार गुरुवार मी काहीच केलं नाही त्या कंपोनंटला, आहे असं टेबलवर ठेवलं आणि गुरुवारी चेक केली तर त्याची 20 RC हार्डनेस आली. व्हॉट इज दिस? दिस इज मॅजिक. पीपल वेर शॉक्ड अर्लियर टू सी दिस मॅजिक. So there is no any magic. There is a technical term called as precipitation. In old syllabus, there was one complete chapter for 7 to 8 marks in the old syllabus as a precipitation hardening. And now it is removed, and only for understanding purpose this ALCU system is kept. And because this is important concept and student must know this, it is now asked only for 3-4 marks. Explain the ALCU system, and only steps are asked. Only steps in precipitation hardening, that is for 2 or 3 marks. I will explain the detailed process, even it is not part of syllabus. So precipitation means what? The solute atom separates every day. म्हणजे तुम्ही हीट करून कूल कलर ठेवलं ना, तरी त्याच्यामध्ये प्रोसेस चालूच राहते. म्हणजे कूल झालंय आणि ठेवलंय तरी आतले ॲटम्स इकडे तिकडे हलत राहतात. आणि ते ॲटम काय करतात, असे एकत्र ग्रुप करतात. ज्यावेळी असे ते ॲटम एकत्र ग्रुप करतात, when they are going to make such groups are called as precipitates. It is not visible by naked eyes. It is only observed by high resolution microscope. Atomic level means angstrom unit level. Now simple question, एक ग्रुप करण्याचा आणि हार्डनेस वाढण्याचा काय संबंध आहे? Okay, you must have this question in your mind. What is this formation of precipitate and increasing the hardness? So let me tell definitions. First definition is difficult to cut, difficult to deform. So difficult to deform means hard. Means if you take this alloy and if you try to deform, what is the mechanism of deformation? Somebody tell. 10 mm ची प्लेट 8 mm झाली म्हणजे काय झालं? एक्झॅक्टली व्हॉट इज द मेकॅनिझम? सौरभ धोत्रे. हर्षवर्धन उबाळे.
Yes, sir.
Please tell what is your understanding. My question is 10 mm plate becomes, what exactly happened?
Sir, dimensions are changing, sir.
अरे सेम थिंग ना, आय टोल्ड डायमीटर इज चेंज, बट व्हॉट एक्झॅक्टली हॅपन? ते मटेरियल कुठे गेलं? एनी आयडिया?
त्याच्या लेंथ मध्ये लेंथ वाढली.
Dhanashri Shunone. Space between the atom is reduced. Actually, you can tell in different way. Not space between the atom is reduced. Atomic layers moves to the forward direction. म्हणजे एकावर एक जे atomic layer असतात ते वरून पुढे सरकतात. That's why length increases and thickness decreases. Are you getting my point? So when atomic layers are moving means if they are moving easily, we can say that it is deforming easily. When it is deforming easily means it is soft. समजा ते डिफॉर्मेशन करायला तुम्हाला अवघड जाते, म्हणजे ते ॲटॉमिक लेयर्स एकमेकांवर पुढेच सरकत नाहीत, तर तुम्ही म्हणता की मला खूप एफर्ट्स लागत आहेत हे थिकनेस रिड्यूस करायला. वाय यू रिक्वायर मोर एफर्ट्स? बिकॉज ॲटॉमिक लेयर्स आर नॉट इझिली मुव्हिंग, मीन्स मोर एफर्ट्स आर रिक्वायर्ड, मीन्स इट इज हार्ड. हे कशामुळे होत आहे? These precipitates, these groups are obstacles for movement of these layers. म्हणजे ते ॲटॉमिक जे सोल्यूट ॲटमचे जे ग्रुप्स असतात ते त्या लेअरला मूव्ह होऊ देत नाहीत, पुढेच जाऊ देत नाहीत. तुम्ही खूप जोरात ढकलल्यावर जाणार, पण यू कॅन फील की इफ इट इज नॉट मुव्हिंग इझिली वी कॅन से दॅट पार्ट बिकम्स हार्ड. कशामुळे झालं? आपोआप हार्डनेस वाढली. ऑन मंडे इट वॉज 12 अँड ऑन थर्सडे इट इज 20. मीन्स त्यांची ताकद वाढत गेली त्या अलॉयची, त्या ॲटॉमिक लेअरला न मूव्ह होऊ देण्यासाठी. सो दिस इज कॉल्ड एज प्रिसिपिटेशन हार्डनिंग मेकॅनिझम. आय होप यू आर अंडरस्टँडिंग दिस कन्सेप्ट. अँड सोमवारपासून मंगळवार, मंगळवारपासून बुधवार, त्यानंतर 1 महिन्यानी अजून जास्त हार्डनेस, 3 महिन्यांनी अजून जास्त हार्डनेस, 5 महिन्यांनी अजून जास्त हार्डनेस. म्हणजे जसं जसं त्या कंपोनंटचं वय वाढत जाते तसं तसं हार्डनेस वाढते. That's why this hardness is also called as age hardening. AGE. स्पेलिंग नीट लक्षात घ्या. AGE, not EDGE. एज म्हणजे वय. So same process is also called as age hardening. So very interesting mechanism. You can Google it and see it. So this alloy, there are all alloys are not showing this process. There are only some alloys are showing precipitation hardening. Beauty of that alloy, त्याची एक वेगळी characteristics आहे. And requirement is that solubility of solute must decreases with decrease in temperature. And second, the precipitate which is formed should be coherent. म्हणजे ते जे ॲटमचे ग्रुप आहेत सोल्यूट ॲटमचे, त्याच्यात ताकद पाहिजे. एवढीच लिचीपिची असतील तर ते तुम्ही डिफॉर्म केलं तर तुटून जाईल ते. आर यू गेटिंग? So second requirement must be fulfilled. Then only we can say that alloy is precipitation hardenable. So automatically, because of formation of precipitate increases. Now there are 2 types of aging. This treatment is called, or this treatment is called as AGEING. So one is natural aging and another is artificial aging. म्हणजे मी काही वेळापूर्वी जे सांगितलं की 1 आठवडा, 2 आठवडे, 1 महिना, 5 महिने हे आपोआप होत गेलंय, ती झालं नॅचरल एजिंग. म्हणजे आज जानेवारी महिन्यात 20 RC, मार्च महिन्यात 25 RC, हे ऑटोमॅटिक. पण मला आत्ताच 30 RC पाहिजे, माझे हार्डनेस आत्ताच मला 30 RC पाहिजे. मी वाट बघत बसतो तर जून महिना उजेडेल. आय डोंट वॉन्ट इट आफ्टर 6 months. देन व्हॉट कॅन बी डन? यू कॅन डू इट आर्टिफिशियली. जी हार्डनेस मला 6 महिन्यांनी मिळणार आहे ती हार्डनेस मला 1 तासातच मिळते. हाऊ? दॅट प्रोसेस इज आर्टिफिशियल एजिंग. सो यू हॅव टू हीट दॅट अँड अगेन कूल सेकंड टाइम. सो दॅट प्रोसेस इज precipitation hardening and artificial aging. And whatever hardness you require, that will be achieved. So this alloy exhibits precipitation hardening. That is the beauty of this alloy. So what is asked in the examination? Explain the aluminum copper alloy and steps in precipitation hardening. हे मी आता एवढं जे सांगितलं ते तुम्हाला नाही विचारणार परीक्षेत, but only steps will be asked. That steps I will explain and we will stop for today's class. 5 minutes. You please drop message in chat box in WhatsApp group. Who is next teacher is I think your CC Jadhav. Okay. So within 5 minutes I will cover, and you can join his class. So these are the steps which I was explaining in precipitation hardening. So this is the same equilibrium diagram. Point number 1 is solution treating, means heating to form the single phase alloy. Okay. Point number 2, quench. Quench means very fast cooling. एकदम पाण्यामध्ये टाकायचं, डायरेक्ट 550 डिग्री सेल्सिअस पासून डायरेक्ट 20 डिग्री सेल्सिअसच्या पाण्यात. ओके. अँड देन एज, 3 नंबर पॉइंट. So what exactly happened, that part I will explain to you in the next class. Okay, because there is a formation of precipitate and you have to draw this figure in the examination. Time being, you take screenshot. I will explain what this dotted part is there. And this is about steps in precipitation hardening, and here are the properties. Okay, maximum solubility of copper in aluminum is 5.65%, and this decreases in continuously with decreasing temperature, and ALCU system with 4.5% copper exhibits precipitation hardening. Okay, so these are the steps. Meaning of the step is given here. Solutionizing means alloy heated around something is there, 500 degrees Celsius. 500 degrees Celsius, alloy heated around 500 degrees Celsius to get single phase alpha. See this diagram. Alpha is single phase. Okay. Percentage of carbon is percentage of copper is 4.5. 4.5 और next straight line काढा, इथे येईल अशी alpha phase to get single phase alpha. But if you cool slowly, again, so at this position 4.5% copper, the phases. Okay. Hello. Phases are alpha plus theta. So what exactly happened and how the mechanism takes place here in the aging, that part I will explain tomorrow. Okay. Shall we stop here? Okay, friends. So tomorrow I will explain this process of aluminum copper. We'll stop and you can join next class. Thank you very much.